Alright, so what I'm going to show you now is how we actually split our cells. So the first thing you want to do before you pull this sash up is we had it on UV. I've now flipped it to on. First thing you want to do is crack it a little bit till you hear the air and that beeping. So what that's doing is it's starting up the fan. So the way these systems work is it's a continual air stream, so that way any bacteria that would make it past this glass, or one now that I have it open, any bacteria that would make it through this is going to get caught in this airstream and go to a filter. So what that does is it keeps everything in here as sterile as you had it before. So you always want to make sure that that fan's running before you open this all the way. So the first thing that we're going to do is, despite the fact that we UV'd, we're still just going to wipe down the surface. So you can either use these, which are ethanol cloths, which are in here right now, or some places will have a UV bottle, an ethanol bottle. So you'll actually just squirt. That's all these cloths really are. They're just alcohol wipes. 70% alcohol should kill most bacteria, so it'd be one less thing you have to worry about. Then usually I try to wipe down both my gloves and any of the bottles that I'm going to be putting in there. The only one I don't usually do would be the flask, just because you have your own cells in here, so on the off chance you get ethanol in there, you're actually going to kill your own cells. So usually don't wipe that guy down. And then the other thing I will need will be in here. I'll borrow someone's PBS. Okay, so the other thing that we'll need is we'll need a PBS, which is a phosphate buffer solution, which is really just a fancy way to call salt water. So the first thing that we're going to do is we're going to take out the residual media that's in here. Any of our dead cells, or just as cells respirate, they pump out waste that goes into the media. So the first thing that we're going to do is take care of that. So the first thing you're going to do is loosen the top, just so that way you can pull it off. We try to always leave things capped, even though this should be a sterile environment. Just in case it's not, we always leave it capped. You'll grab one of these, which these are different than the other ones because they don't have a cotton filter here. What you'll do is you'll pull that out. You'll attach it to the hose here, and then you're just going to turn on the thing back here that says vac, which is just a vacuum. And then pull it up, and usually I try to stick the actual tube down away from where the cells should be growing, which is this back wall. Suck up the media, and you can be able to pull this out. Put the top back on right away. Let that drain for just a second. And then I'll pull this guy off and throw him away. So, now that that's done, what we need to do is we need to wash the surface with this phosphate buffer solution. So one of the solutions that we'll use next is called trypsin. Inside our media is actually a compound that will inactivate trypsin, which is great, so that way it doesn't actually chew up our cells. But when we actually want it to chew up the collagen that's holding our cells down, that doesn't work out so good. So that's why we use phosphate buffer solution. It should help take some of that away. So I will use a 5 ml serological pipette. Put it on our electric pipetter here. And I usually wash the surface with somewhere between 2 and 5 mils. You don't have to get real specific. It's really just to kind of help wash down the cell surface. You're going to want to do it lightly. You don't want to blast away your cells. You really just want to take care of any residual media that might still be on there. So I usually just cap it and then just kind of lay it flat, tilt it back and forth, just wash the surface. And then we will once again loosen the cap, and we will suck that part out. Okay, now the next part we need is to grab some trypsin. So what trypsin does is cells, the way they attach to this growth surface is usually collagen and different fibers. What trypsin will do is it'll actually chew up those fibers first. If you leave it on there too long, what it'll actually start doing is chewing up your cells as well. So you don't usually want to let it sit on there for much longer than 5 to 6 minutes. And the way we do it is we actually speed it up a little bit too by putting it in the incubator. You can leave it at room temperature if you want to, but it just makes it go a little faster. The cells come off a little better. So now the important thing with trypsin is you need to decide what you're going to do with your cells once you take them off the surface. So if you want to have a specific number in mind, you're going to want to think about how much trypsin you're going to add, because usually we add, whatever we add of trypsin, we add at least that much of media to inactivate it later. So if you're trying to get a really concentrated cell sample, you don't want to put in 10 mils of trypsin and then have to put in 10 mils of this, that's 20 mils, you just diluted your sample a lot. So usually what I try to do is, depending on how thick the cells are, I usually do about 2.5 mils. That should be enough to cover the growth surface with enough trypsin to actually take the cells off without actually diluting your sample too much. So then we'll just cap this. Again, we'll kind of wash the growth surface a little bit. And then we'll put it inside the incubator here for about 5 minutes. Alright, so our cells should be about done here. So we'll take them out. Now generally speaking, if this was a real culture, what you'd see is a lot of this liquid down here should be cloudy. And so what that tells you is that the cells have actually come off the surface and are now floating in this solution. So now what we want to do is we want to deactivate that trypsin so it doesn't start eating up our enzymes. So again, we'll just loosen all of our caps. And we'll pull this guy out. So since we put in 2.5 mils of trypsin, we will add 2.5 mils of media. And then usually what I like to try to do at this point is just kind of wash the surface, and if you can do it kind of forcefully, what that does is it helps to get any cells that might still kind of be left on that surface off, to get that off. Okay. And so now what we will do is, you have one of two options. So what you could do is you could take up, usually we split it half and half, take half out of here and put it into a new flask. Or if you were going to use these for an experiment, you would actually pull these up and then put them either in one of these tubes if you have a small enough volume. We have microcentrifuge tubes here. Or else, up there along that top part there are conicals. So we have 15, which are the smaller, skinnier ones, or the 50 mils, which are the bigger ones. Again, kind of depends on the volume that you're using, will kind of dictate how much you need. And then from there, what you could do is you could go on to counting them and then plating them for an experiment, or something like that. So now what we would do is, if we were to pull this out and put it into a new flask, we'd split it. Then what you're going to want to do is, for these T75s, which essentially just means they'll fit about 75 mil, or the growth surface is 75 centimeters squared, or cubed, excuse me. Then essentially what you're going to do is, these fit about 10 mils for adherent cells. So what we'll actually do then is, since right now we have 5 mils in there, we will then add another 5 mils. Into our flask. And at this point now, these would be ready to go right back into the incubator and go back to growing. And then again, what you can do is, usually within about, for the MC3T3 cells, it's usually about 4 days or so, depending again how much you dilute them, how much you get rid of. You'd have to come back in about 4 days and split them again. So you'd repeat this exact same thing. If you didn't want to make another flask, all you'd really have to do is suck out, if you had 10 mils in there, you could suck out 9, throw away 9, add 9 mils back in here of fresh media, and then put them back and they just keep growing again. And so really what you want to do is you just want to make sure you take care of them, because once they get to a point where they completely cover this, the cells will actually change and stop growing. Because once adherent cells reach their max surface area, they can't find any place to grow, they won't actually start growing on top of each other. So then what they'll actually do is they'll start going dormant, so that way they no longer grow, they no longer split and divide. So you always want to make sure that you never get to that point, you never get to that 100%, and for sure, if you're going to do an experiment, you never want them at that, because then they're acting different than how you would normally expect them to act. But other than that, that's all there is to it.